Welcome to the Gen 5 Scissors online service training. This lesson is developed to familiarize you with the Genie Gen 5 scissor products, hydraulic, and electronic control systems. This section will familiarize you with the chassis, linkage components, platform, and component locations. This course concludes with a final exam. You must pass the final exam with a score of 80% or better, to complete the course. A certificate of completion can be printed after successful completion of the final exam. Photographs and documentation are for reference only. Read, understand and obey the safety rules and operating instructions in the appropriate operator's manual on your machine. This course covers the GS30, GS32, GS46 and GR products. Product-specific serial number plate, and serial number steel stamp locations, can be found in the service manuals, along with a description of what the entire serial number means. It is always critical to know the serial number of the piece of equipment that you are working on, to ensure that you have the proper documentation or information for your specific machine. The GS nomenclature applies to all scissors products. GS stands for Genie Scissors Lift. The first two digits of the four-digit model number define the height of the platform floor in feet, when the linkage is fully elevated. The last two digits define the width of the chassis in inches, at its widest point. Fully elevated, the GS 1930 deck is 19 feet from the ground, providing a 25-foot maximum working height. The chassis is 30 inches wide, which allows it to be driven through a standard main door. The product familiarization section of this lesson is pictorial walk-around of the GS 1930. The purpose is to familiarize you with component locations, and will also give descriptions of components' functions. The walk-around starts at the base of the machine, describing the chassis, components, and connections. The linkage components section continues in the base chassis, with the pothole arms and actuators, and will transition up to the lift linkage, as they are tied together in operation. As we wrap up the lift linkage, components, and connections, we will move up into the platform, showing the platform controls and documentation box. Pictured here, is the non-steer, or rear end of the chassis. On the non-steer end of the chassis, the manual brake release manifold, pump and dump valve, power to platform plug, and emergency lowering T-handle, are located behind the ladder. Spring-applied parking brakes are bolted to the rear end of the chassis. Non-marking tires are standard. Chassis tie-down points are located on the rear of the chassis, and craning points are on the sides of the ladder. There is no carbon in non-marking tires, so the chassis is isolated from earth-ground, creating a potential for static electricity that could possibly cause component damage when discharged. To protect against static buildup, anti-static straps are installed beneath the chassis. The left-hand side of the machine houses the battery tray. The following pages will show and describe the components located inside of the tray. Shown with the battery tray open, 4T105, 6V, 225 amp-hour, deep cycle batteries are connected in series, supplying 24 volts to the control system and pump motor. These batteries are used in all the GS and runabout products. They are used for counterweight and should be replaced with batteries of the same weight. The Signet battery charger is also common throughout the GS and GR product lines. The Anderson-style battery quick disconnect, QD1, should be disconnected when performing maintenance. A 275 amp main power fuse is in place to protect the batteries, motor, and motor controller. This is a rear view of the Signet battery charger. Charger interlock wires are standard, but may not be installed on your machines. There is a female connector on one wire and a male connector on the other, that can be installed in line with the wire on terminal 1 of the DC motor controller. This interrupts machine operation while the charger is connected to a power source. This aids in eliminating the possibility of pulling the charger cord from the machine, while connected to an extension cord. The yellow jumper wire is closed for wet lead-acid batteries. Cut the jumper, and cover the bare wire ends, in applications where gel batteries are installed. The red and black wires are the output wires connected directly to the batteries. The faceplate on the charger has status LEDs, to display the state of charge throughout the charge cycle. They're also used to flash fault codes, along with an internal audible alarm. A quick disconnect IEC plug is used for AC power. This charger automatically adapts to 110 volt, or 220 volt AC inputs, and to 50 Hz, or 60 Hz. This enables the charger to be used anywhere in the world, by simply changing the power input cord. This is the steer end of the machine, otherwise referred to as the front, or drive end. Craning and tie-down points on the front end of the machine are made visible with decals. The steering system consists of a tie rod weldment that is connected to the steer yokes, and a dual-acting steer cylinder. Fixed displacement roller-style drive motors are used. The right-hand side of the machine houses the ground control panel and hydraulic reservoir. The following pages will show and describe the components located inside of the tray. The ground control panel houses a 7-amp circuit breaker that is in place to protect the electrical control system, a key switch to select platform operation, power off, or ground control operation, an hermeter that counts time while the electric motor is running, the platform up and platform down toggle switch, emergency stop button, and the LED display window and decal to explain fault conditions and codes. The LED display shows a dash for normal operation. ECU software revision is shown when the down function is selected. The software configuration is shown when up is selected. Note that the software revision and configuration are not fault codes and are only displayed at the base control so not to confuse the operator. Fault codes are displayed as long as they are detected. With the hydraulic component tray open you can see the return filter location, and a control relay, CR48. This is the only relay on ANSI market machines. The power unit assembly is comprised of a series wound, DC motor, and a fixed displacement gear pump. Proportional controls are achieved by varying the electric pump motor speed, with the use of a DC motor controller. The ground control panel components are easily accessible by removing 2 screws from the face of the panel. The ECU monitors user inputs, and provides outputs accordingly, within the safe operational range of the machine, as defined by inputs from the limit switches and sensors. These are the different types of motor controllers that we use. The Curtis motor controller on the left, and the Kinetec motor controller on the right. This is a view of the function manifold from the hydraulic side of the machine, with the tray open. All of the solenoid-operated valves are on this manifold, except for the down valve, which is located on the lift cylinder. Notice the battery negative bus connection for all of the solenoids. If this plug is loose or misplaced, none of these functions will operate. A coil fault will be displayed, as any one of these functions are selected. The small manifold on the return to tank line is a 200 psi check valve that prevents fluid draining from the hydraulic system and assists with brake release while driving the machine. A 180 psi nitrogen-charged accumulator is plumbed in parallel with the drive system to help keep the brakes from locking up or dragging while driving down a decline. The pothole linkage is shown looking toward the rear firewall from the hydraulic side, with the component tray open. Pothole pusher rods activate the pothole arm linkage, retracting the pothole arms when the lift linkage is stowed. The limit switches are held open in the stowed position, and relax to close as the gas struts assist to fully deploy the pothole protection arms, as the lift linkage is raised. The pothole protection arms are deployed to make the machine stable, in the event that the machine is driven off of a flat and level surface. If the ECU does not recognize that the pothole arms are deployed when the linkage is out of the stowed position, lift is allowed to continue, but drive is disabled. This view shows the pothole pusher rods on top of the non-steer end of chassis. They are activated by the lift cylinder mount bracket on the linkage, when stowed. The safety arm chock should always be in place when attempting to access, or service inside of the lift linkage, or on top of the chassis pan. The lift cylinder can safely be completely removed, with the safety arm chock in place. These components are located on top of the chassis at the steer end. Deutsch plug connections are made to connect the down limit switch, tilt level sensor, and multifunction alarm, to the chassis harness. On this particular machine, the Deutsch plug connection for the control cable is made on top of the chassis. It may also be located beneath the chassis pan, in front of, or behind the front firewall. The platform control box can be connected directly to this Deutsch plug if the control cable is damaged inside the lift linkage. The tilt level sensor is normally closed, and opens at 1.5 degrees to either side and 3 degrees to the front or back, compared to gravity. This will not sound an alarm unless the linkage is out of the stowed position, at which point, lift and drive are disabled. The down limit switch is forced closed by the linkage when in the stowed position. It relaxes and opens when linkage is out of stowed. The ECU disables lift up and drive if the pothole arms are not deployed when the linkage is not stowed. A bus connection for a common battery negative connection is located on top of the chassis, as well. On the lift cylinder port block, You can see the lift and return hose, and the platform down solenoid valve with the knurled knob for the manual override cable. It is important to understand that this valve is bearing the entire load of the platform and linkage. The platform is shown here with the deck extended. This accommodates a 4-foot by 8-foot sheet of drywall or plywood. A lock pin secures the extension deck in the fully retracted, half-extended, and fully extended positions. Power to platform with GFCI outlets is standard on GS products. Lanyard attachment points are also standard on GS products. A literature box is located on the front of the extension deck, to accommodate proper documentation and inspection forms. Every piece of aerial equipment must have an ANSI manual of responsibilities, a model and serial number specific operator's manual, and an AEM safety manual at all times. The platform control box is used for typical operation from the platform, and may also be used for diagnostic troubleshooting, as an adjustment tool for speed tuning, or for software configuration. It features a Hall effect joystick, and steer rocker. The joystick adapts to neutral on machine power up, within 50% of the joystick stroke. This eliminates joystick out of neutral faults. Green LED illuminated buttons are located on the printed circuit board for lift and drive mode selection, low, or turtle drive speed, along with a horn button that is not illuminated. A function enable switch is located on the front of the joystick, which must be activated to enable any function from the platform. The state of the control system voltage is shown with a maximum of 6 solid bars at full charge, decreasing to 1 flashing bar, when the machine is in low voltage cutback. Low voltage cutback causes functions to operate extremely slow, allowing the machine to be moved to a charging station without damaging electrical components. On the steering component slide, you saw the Deutsch plug connection for the chassis end of the control cable. The coil cord from the platform control box connects to the Deutsch plug connection at the other end of the cable beneath the platform glide channel. This allows you to disconnect the platform controller and plug it in at the base for diagnostic purposes.